Assalamualaikum and good evening. I be to our solid mechanics lecturer, Dr. Nur Safrina Ahmad. So we are from Group 1 from class EC220-4C2A want to present our project. And my group members are Zaki, Zairi, Nur Sabrina, Izzat and myself. So basically, we are required to do a project that required us to propose a footbridge for case A1 which the loads are pedestrians and light motor vehicle. Then we need to determine the stress and the deflection of the beam using StartPro software and compare it with manual calculation using double integration method and moment area method for the results. So these are the picture of our truss footbridge in 2D and 3D sketches.
Today I will present about the objective and specification of the solid project.
So the objective of this project is to identify an idealization of real structure solving using related topic and method required. Then to analyze the stress and deflection and validate using modern analysis tool. Okay, next is for specification. The size of section is 0.5 times 0.6 meter. The area is 900 centimeter square. The IYY value is 270 times 10 to the power of 3. IZZ value is 19.9 times 10 to the power of 3. And the material that we use is concrete. For the material, we use the concrete. The electricity of concrete is 21.718 kN per meter square. The Poisson ratio of concrete is 0.170. The density is 2.4 times 10 to the power of 3 kg per meter cube.
And now I am going to present about manual calculations. The first thing you need to calculate is the design load. To calculate design load, you need to use the formula W equals to 1.35 GK plus 1.5 QK. So GK is the dead load. We made an assumption that the total surface of member is equal to 10 kN per meter. For live load QK, for pedestrians, 400 times by 15 times by 9.81. 400 is the distributed load on bridge structure. 15 is the total length of the bridge. And then we get 58.86 kN per meter. For vehicle, 375, which is a distributed load, times 15 times by 9.81. Same concept, and then we get 55.18 kN per meter. And then we substitute the value that we get into the design load formula. Finally, we get 184.56 kN per meter. According to the StartPro software, the shear force diagram, the maximum shear force that we get is 1406 kN. Meanwhile, while doing the manual calculations by substituting into the maximum shear force formula WL/2, we get the answer is 1384.2 kN. And then lastly, we calculate the percentage difference and we get 1.55%. The bending moment diagram that we get from StartPro, the engineering software, the maximum bending moment is at midspan, which is equal to 5271 kN. On the other hand, by using the manual calculations, by using also the formula WL²/8, we get the maximum bending moment is equal to 5190.75 kN. And then we find the percentage difference. We get the percentage difference 1.52%.
Now I will present about the calculation for shear stress and deflection. The calculation of shear stress using StartPro, we get 0 Newton per millimeter squared. While using manual calculation, we get 0.006 Newton per millimeter squared. The percentage difference between StartPro and manual calculation is only 1%. The calculation for deflection, we use two methods, which is double integration method and moment area method. For double integration method, we get the deflection is 7.225 times 10 to the power of -4, while for moment area method, we get -2.253 times 10 to the power of -4. The percentage difference is only 1%.
Now I will present discussion for this project. Based on the result, we can see that there are percentage difference in design analysis by the software and manual calculation, which depends on theory class. This difference might be due to a few factors such as seismic effects, wind effects, clear depth and other properties, which depends on the codes that we have been used in the software, and this code might be taken into a consideration by the software to ensure that the structure that we design are in a stable condition. Now I will present on conclusion for this project. In conclusion, many aspects need to be considered when designing a bridge. The checks that have been carried out will help to ensure that the proposed model of the structure has no mistake and also in a stable condition. As a recommendation, it will be much better to check the design and analysis by using more than a single software such as LUSAS and STEAM to avoid any unusual results before proceeding any mega or important project in a real-life application. By this, any loss to a budget and life may be preventable.